In this module, we talk about how large language models work and why they fail. Artificial intelligence systems, particularly large language models, are often described in ways that suggest understanding, reasoning, or even intent. They appear conversational. They explain concepts. They generate fluent, confident responses. This surface behavior makes them feel intelligent in a human sense. That perception is dangerous. To manage AI risk responsibly, especially in high stakes environments like finance, it is essential to understand what large language models actually are, how they function, and most importantly, why their failures are not anomalies but structural characteristics. What large language models actually do. At their core, large language models do not understand language. They model probability. Given a sequence of words, a language model predicts what is most likely to come next based on patterns learned from vast amounts of data. This process is statistical, not semantic. It is pattern based, not conceptual. It is correlational and not causal. The model does not know facts. It recognizes relationships between symbols. Meaning is inferred by the user, not possessed by the system. Why fluency creates false confidence? Language models are optimized for fluency. They are trained to produce text that sounds coherent, relevant, and contextually appropriate. This makes their outputs persuasive even when incorrect. Humans instinctively associate confidence and clarity with competence. This cognitive bias causes users to overtrust AI outputs, especially when they are well articulated. The risk lies not in obvious errors, but in plausible ones. Consider a common scenario. A professional asks an AI system to summarize regulatory requirements relevant to a specific transaction or reporting obligation. The response is polished, structured, and confident. It references concepts that sound familiar. The language aligns with expectations, but one key interpretation is subtly wrong. No warning appears. No uncertainty is expressed. If the output is accepted at face value, decisions downstream are shaped by an error that feels authoritative, not because it is correct, but because it is well written. Training data, the foundation and the constraint. Large language models learn from massive data sets drawn from text created by humans. This training data encodes knowledge, assumptions, biases, errors, and gaps. The model does not distinguish between truth and falsehood during training. It learns what patterns appear frequently, not what is correct. This means models reflect the statistical properties of their data, including its limitations. Garbage in does not always produce garbage out, but it shapes everything. Why models cannot know when they're wrong? A critical limitation of language models is the absence of epistemic awareness. They do not have an internal sense of truth, confidence, uncertainty, or verification. When asked a question, the model produces an answer even if it lacks sufficient information. This leads to hallucinations, outputs that are syntactically correct, contextually appropriate, and factually wrong. From the model's perspective, this is not failure, it is completion. Hallucinations are not bugs. Hallucinations are often described as defects to be fixed. In reality, they are a natural consequence of how language models work. When a model is prompted to generate text beyond its training support, it fills gaps probabilistically. It does not stop and say, I don't know, unless explicitly trained or constrained to do so. This makes hallucinations predictable, not exceptional. Why reasoning is an illusion? Some AI outputs appear to demonstrate reasoning. In truth, language models simulate reasoning patterns that they have observed. They reproduce the form of reasoning without possessing the underlying logic. This distinction matters. The model can explain a concept convincingly while misunderstanding it entirely, because explanation is just another pattern. Context windows and fragmented understanding. Language models operate within finite context windows. They do not maintain persistent memory or holistic world models. They process information locally within the prompt and recent interaction. This leads to inconsistencies across responses, loss of earlier constraints, and conflicting conclusions. What feels like conversation is actually a sequence of bounded predictions. Why models are sensitive to prompting? Because outputs depend heavily on input framing. Small changes in prompts can produce dramatically different responses. This sensitivity reflects ambiguity in language, lack of grounding, and dependence on surface cues. This makes models powerful and fragile. Prompting is not programming, it is influence. The absence of intent and accountability. Language models do not have goals, intent, or accountability. They do not understand consequences. They do not care about outcomes. Responsibility always lies with the humans and systems that deploy them. This distinction is critical in regulated environments. Why failures cluster around edge cases? Language models perform best on common, well represented patterns. They fail most often when questions are novel, context is incomplete, stakes are high, and precision matters. Unfortunately, these are exactly the situations where human users seek assistance. The mismatch between confidence and correctness becomes most dangerous at the edges. Why this matters in finance and governance? In financial contexts, errors are not academic. They can influence investment decisions, risk assessments, compliance interpretations, and strategic judgments. A fluent but incorrect output can mislead decision makers who assume competence based on articulation. Understanding model failure is therefore a governance requirement, not a technical curiosity. Designing around predictable failure. Effective AI governance does not aim to eliminate failure, it assumes failure and designs controls accordingly. This includes human review, clear use case boundaries, output verification, auditability, and escalation paths. Systems should constrain AI behavior where precision and accountability matter most. Why AI safety begins with mental models. Many AI risks stem from misunderstanding. When users believe models understand, reason, or know, they delegate too much authority. Correct mental models reduce misuse. AI safety begins not with controls, but with clarity. The key takeaways here are: large language models generate language, but not understanding. Their fluency masks structural limitations, lack of truth awareness, susceptibility to hallucination, and simulated reasoning. These failures are not defects to be patched away, they are inherent properties to be managed. Responsible use of AI begins with understanding how and why it fails.